Okay, welcome. Thank you all for coming. This is Raku Next Steps, Hyperactive, Metang. Starting to think in Raku with meta operators like Z, X, reduce, hyper. Part one of an intermediate Raku class. No, it's a talk, not a class. More on that later. Abridged. Very. There should be an image here capping off a great joke on this presentation name and how NG means next generation, and Metang in the Pokemon world is made of two fused Pokemon like our meta operators are fusions, and it turns out that Pokemon are copyrighted and trademarked and probably patented, so no AI drawing of a hyperactive Metang here. Quick preference and introductions. I am Bruce Gray, util online. I've been working with Raku for over 20 years. Raku is the language that is essentially Perl, improved and carefully aged in casks of awesome. You'll hear me pronounce the language name as Raku sometimes, Raku sometimes. Both are valid. Raku is slightly more correct. If you want to experiment during this talk and you don't have the Rakudo compiler for the Raku language installed, then the glot.io website will allow you to very easily play around with it. Finally, I want everybody to hear me easily without straining. If my volume drops, please tell me. My plan was to cover a quick review of plain old operators, the concept of meta operators, and then for each of reduction, production, interlacing, cross-product, and parallel execution to show how the Raku designers did put a form with all the bells and whistles in, but then went further to simplify them into a form so useful and so compact that it'll start to elevate your thinking about your coding. And then to also cover combinations of meta ops and unexpected uses that have developed over time, corner cases, traps and gotchas, and then multiple ways to do things that have developed from those unexpected uses and how to detangle those ways to do it to give clear advice on when to use which option in 45 more minutes. No. This was envisioned as a 3 to 4 hour class, like with involvement and exercises and all. And then reimagined as an 80-minute talk and then reinvented as a 50-minute talk. We're not going to get through it all. The seams are going to show through in places, which also means we're going to have to take some time if there are any clarifying questions, like the hypotheticals and the deep stuff, that can wait for Q&A, but if there's something like, I just did not convey what I thought I conveyed, and then I'd love to answer that in real time. But that takes time too. This is a solid talk, but only if I don't try and fit so much in that everybody's eyes glaze over. So I'm sorry not to be able to deliver the full measure of the awesomeness that this topic deserves. Operators. We covered them in the beginner's class last year and the year before that. The second half of that class has been missing from YouTube for about 8 months. And my hero, J.E. Turcotte, recovered it. So now both halves are available at those URLs. Let's quickly review a few aspects of operators before we get meta. Any symbol on your keyboard can mean different things depending on where it's used in your program. Just like in Perl, the slash could mean division, or the slash, same character on your keyboard, might indicate the beginning or the end of a regular expression. In Raku, we use this principle even more. The left angle symbol, if it's between two terms, it's the less than operator. But if it's in a term position, then it's the start of word quoting. QW from Perl. Lots of people write the word quoting with no space there, just be less ambiguous to the reader. but it's never ambiguous to the compiler. It's about term position and other positions. Also, wherever we have way cool Unicode symbols as operators, we have old school ASCII equivalents. So if you see me using Unicode stuff, say, I don't know how to type that, there's always an ASCII alternative. In 2004 and 2009, Mark Lesner created a periodic table of the Perl 6 then operators. It's a little out of date, but it's still a work of art. And you don't have to learn it all, right? And you probably already know a lot of it, like basic math ops and comparison operators. There are lots of groupings in this table. I mean, if you zoom in, it's much like the atomic table. It's really well crafted. I mentioned math operators and comparison operators. If we continued on with that kind of grouping, we could also talk about string ops and logical ops and others by their uses. Not today. Today, we're going to group prefix, postfix, and infix. What's the difference? The exponent op in green, that's infix. It is in between its operators. In between its operands, the 5 and the 2. The green plus and the green tilde are also infix. They're in between the operands. The blue plus is a prefix operator for numeric coercion. Raku knows it can't be the infix plus because there's no term to the left of it. These are two different operators, addition, numeric coercion. They're just spelled the same. And the plus plus is an example of a postfix operator, comes after its argument. Back on the chart, all of these in this color, this olive green, those are all colored that way because they are infix operators. That's what we'll be mostly focusing on. Completely, given how much time we have. Now, meta operators may be a new concept, but we're all familiar with at least one meta operator, op equals, in the form of plus equals. Those two statements are always equivalent, right? They're completely interchangeable, just one's better than the other. Many languages support plus equal. Quite a few support other op equals besides basic math. Like this would change foo by a rightward bit shift of 1. That works in C too, well, without the $sign. Raku has some built-in functions that are also defined as infix operators, which seems really weird. It seemed weird to me to say like C equals A max B, an infix operator. I want that to be like a subcall or something. But in defining it that way, that lets them do a max equal, so you can loop through and always track, with a constant, that's bad. But anyway, you can use it in meta operators. So we have things like GCD is defined that way. The Raku design goes the full mile and declares that every infix operator has an op equal form. In fact, if you create your own operator, which is dirt easy to do, Raku automatically creates the meta operator your op equal. So on to the new meta operators. Reduction. There's a reason I start with this, but unfortunately it's kind of the heaviest one. Reduction is a concept from functional programming where you reduce multiple values to one value, like reduce many to one via some kind of accumulation process. Oh, there's a stray dot there, right? That's going to be on some of the slides. It has to be there. It's not actually part of the code. Please act like it's not there. If you copy code into Glot, take it out. Sorry about that. It's just for spacing. Okay, let's derive the abstraction of reduce, starting with a familiar procedural approach. We've got 3 routines here: sum, product, join. Any one of those 3 should be straightforward for anyone to read and understand. There's lots of similar structure between the 3. We like dry code. Don't repeat yourself, right? Some of that is obviously repeated. Some of it looks unique, but is actually repeated. And a tiny bit of it is unique. We're going to massage these down to make the separation clearer. I'd given the accumulator variable different names based on what they held. Or in the case of join, because I couldn't think of anything, just ret for return variable. Well, let's rename it based on what they do, which is they're accumulating. So ACC's for accumulator. We don't have to name the iterating variable. We have the topic variable. Everybody's comfortable with that. The input array can have a generic name. That'll help. I'm going to rename the accumulator that I just renamed from ACC to A for the obvious reason of not making the next slide overflow. We're going to change to postfix form. Okay. Now we can see better parts that are unique and parts that are common. We're going to extract the pattern and call it reduce. Lots of languages have reduce built in, especially functional languages, because they can't use accumulators, because their variables don't vary. So everything's repeated except the initializing value and the operation. Everybody get that? So we're going to use sum as the base of our extraction. This is a straight copy from the prior slide. Since we'll be messing with the operator, let's unmeta that plus equals and flatten it out to the same statement, but saying A twice. We're going to rename it reduce, because that's what all the languages call it. 0 is the initializer, and that needs to become a parameter. Now, trickier, we're going to have to change the addition to a generic operation. That operation is going to take 2 parameters, 2 arguments, just like plus does. Oh, that doesn't show up when I do that. Okay. Does it? Oh no, I can't highlight it. I can't point at stuff. Okay, I'll remember that for the future. I don't think it used to work that way. All right, I'll just do it for myself. So now operation's not defined. It's got to become a parameter too. I'm using that ampersand when code is passed. Well, what the ampersand does is first, it says, if you pass something in that position, it has to be code. It just automatically checks to make sure it's code. Second, I can refer to that subroutine that's getting passed in, that code that's passed in, as if it was named operation. No matter what it was named on the outside world, or if it had a name at all. Now, this is a full abstraction. It is dry. It's very close to the actual reduce function in lots of languages. So if we have this code defined somewhere, then instead of having to write these, we can just do this. Whenever you want to have a sum, you would type out reduce and a code block with a plus b. The parameter you want to take the sum of, and 0. You got to initialize to 0. Don't initialize to something else. Does this look superior yet? You got to have faith that we're going to go somewhere better. And if you think you would like to avoid writing out those reduce statements every time you want a sum or a product or a join, like so, right? Just wrap them in subroutines with decent names. I would agree with that. This is very reasonable, commendable. JavaScript would like a word with all of us. I think I looked at 20 pages online, the top Google searches on how do you do a sum in JavaScript. And fully half of them said, that bottom line, type that out every time. No mention of encapsulation. Just memorize that and cargo cult it and hopefully understand it. No. So while our instincts are all to wrap this in a subroutine, wrap the reduce, the Raku designers saw how to tighten it much further. This is where we left off. If we presume that there are at least 2 elements in the list, and the logic to handle 0 elements or 1 elements is another class. If we presume there's 2 elements, then we can make this change. Instead of using an initializer, we're going to use the first element from the array. And instead of going over the entire array, we're going to use .skip to say the entire array except the first one. Now we don't need the initializer anymore. And our the only thing we have to pass in uniquely is the operation. So they had a syntax added for exactly that. We don't have to have these, which makes those fail. And that's our syntax. Square brackets around an infix operator is a reduction. That is sum, product, and join. And if you've never seen it before, it's Greek. But square brackets wrapped around an operator is not but a tiny bit of syntax to add to your head. And once you've got that, you read it, and hopefully you find places you want to write it. That is really compact.
Yeah.
So we've gone from loops to just an operator in a square. It's like the tiny square replaces a larger circle. Yes, sir.
You use head in the previous slide. Does the reduce essentially shift off that first element so that every time you do reduce, you're moving into the next subsequent elements, or do you have to actually use shift operators or array operators?
The question is, does head essentially affect the the input array. And I don't know if you're thinking from other implementations in other languages where there's recursion that's in play. No, head and skip do not affect their argument. They just affect the return value. So if I say ABC, it like word quote ABC, no, A space C, A space B space C, end word quote, dot head, that's fine. I'll just get B and C. No, I'll just get A. And if I say dot skip, I'll just get B and C. And you can give it parameters. I can say I want the first 3 from the head, or I want to skip 5. Did anybody get that before I take this next question? You get it. Good man. I thought only David Adler would get it, and he not here anymore. Yes, sir.
Sorry if this is too beginner or vague or anything, but I'm just curious, are accumulation and reduction kind of two sides of the same coin as far as the naming for this?
Are accumulation and reduction is two sides of the same coin. Reduction is the higher level abstraction of accumulation. Is that a good way to put
I
it?
don't understand why, but I guess it makes sense. I can just take that for granted, I guess.
Okay. He said he doesn't understand why, but he'll take it for granted. And maybe...
For some? Oh, I see. So it's just a specific... It's not for some? Okay. But we could call reduction accumulation in some abstract way if we wanted to, right? I mean,
We could call reduction accumulation in some we could just change the names. Yes, but there are other things you can do. If you think about it, there are quite a lot of other things you can do with accumulation that is not reducing to one value. And so reduce is a little more on the nose.
okay, got it.
And I haven't had a chance to say, but we have a hackathon tomorrow, and I'm going to be around for that whole thing. And so some of the questions that you have, if I defer you, I still want to talk to you hallway or dinner or the hackathon tomorrow, or email after that. And that goes for all you online too. Okay. Now, we do have a method form of sum in the language because it's just so common. And we have a method form of join, both because it's common and because you sometimes want to give it parameters, what you want to join on instead of just put everything together. But sometimes you'll choose to do it the reduce way because of precedence. I don't have a slide for it, but the precedence of, or the way a method call would work is you have to have a group of something. Like if you're going to have 3 things, you got to put those 3 things in parenthesis and put .sum at the end. If it's already in an array, then it's easy, fees.sum. But the precedence of reduction is rightward. It's the same as a subroutine call. So if I put square bracket, star, close square bracket, everything to the right of that is the stuff that gets multiplied. So sometimes I try it 2 ways and see what works best, what looks best, what reads best. Oh, and if you're looking for factorial, I have some slides later that I may skip over, but in production, there's an even better way. It's incredibly cool. Okay, so all that to say that's more than you want to be thinking about. This is the way they really ought to teach it. This is the way it really works in the Raku world. You have to know it a little deeper in some other places. But if I say op in square brackets and there's a list of things, I mean the first thing op, the second thing op, the third thing op, all the way. You just think of it like that. Spew it out and put the op in between each one. That makes sense? Is that an easier way to grasp it? Okay. So that's clear. What does that do? Now, some of you already know, and I appreciate you not shouting it out. I'll give you a clue. So that very bottom line is it spun out less than in between 3 arguments. The middle section is actual code. You can copy and paste. The first line is true. The second line is false. Does that give you a clue?
It's a test for sorted order.
A test, okay. Yeah, I heard a test for sorted order, or LT order, which are not the same thing. They're almost that close. Strictly sorted order. If I said LE, then it would be sorted order. But as it stands right now, if I had Alice, Bob, Carol, then it would fail because Alice is not less than Alice, right?
So it's unique sorted.
Yes, sorted, unique, or I think the math terms strictly sorted, or strictly ascending or descending. So there are a couple of places where I don't know if it's intended because I can't read Damien's mind, and I should be thankful for that. But
I've tried. It's not fun.
Someone's tried. It's not fun. Limbark. So there's some stuff that's been unexpected to me, sticking an operator in between there and getting an interesting bit of functionality.
That one actually is a really nice
Yeah.
operator.
It is nice. There are places where you don't want to expend the energy to sort if it's probably already sorted, or you want to require it to be sorted, and it's so much more efficient to check that it's sorted instead of doing the sorting.
The other very quick thing is if you do this, it makes a one-line OK test. You try to implement something like a binary tree.
Mm-hmm.
OK, LT, this thing.
It's a one-line OK test.
It's a one-line OK test for an entire tree.
For an entire tree. It's funny you say that. Although,
The next slide is a tree.
well, yes, it is, but
Slide was the tree.
yes, the next slide is a tree, sort of, but that is actually an independent point that I'm glad to hear, and I'll take time later to process it. Independently of that, but coincidentally about trees, during the development, Audrey Tang noticed that, okay, so third line, my tree equals, what happens if you put a pair constructor in a reduction? Then you get a tree of A points to B, points to C, points to D, points to E, which in Lisp is linked list. I don't speak Lisp really, but apparently that is pretty cool to be able to just do. And it would look like this or like that, depending on how you like your trees drawn. Okay, so that's all reduction. And it's in Perl also, in probably list utils. Related is production, or the triangular reduce, which oddly in list util is called reductions, plural. So the same name, reduce in Perl and Raku, but it's reductions and produce. I think produce is much cleverer in the two languages. So we've covered this, right? Add up all the numbers from 1 to 6, it's 21. If I put a backslash in front of that operator, then it doesn't reduce to one value. It produces all the intermediate values concluding with the final value that you would have reduced to, which does not come up nearly as much, but when it's a good fit, it's a great fit. An interesting development from that is, you don't think about it, but comma is also an operator. So what is this going to do? It's going to give me A, then A comma B, and then A comma B comma C, and A comma B comma C comma D, which occasionally, if you're like doing the weekly challenge, is useful. And I won't get into how this works, but there's an ultra cool thing where we use lazy lists here. We have an infinite list of 1 to infinity, and you can create a auto-caching factorials that after you look up 10 factorial, it automatically knows 1 through 9 from then on and won't calculate more than that unless you ask for more than that. It's very efficient. Okay, how are we on time? 30 minutes more. 20 minutes more. That is different from 30 minutes. 5 of which is Q&A. If we don't get it all done during. Z, or Z, is both a standalone operator and a meta operator. Unlike reduce, which you've just put square brackets next to each other, you created it's a array constructor. As an aside, I see every single one of these forms of looping over array indexes in other people's Raku code. In my opinion, the first or even the second, if you prefer, are clear and the rest are not. Let's split that line to make it clearer, make the font bigger. It's still the same line though. So somewhere above, we have 3 arrays defined: names, address, postal, because I'm not going to call it zip code when I'm going to be doing some zipping somewhere in here. So names, addresses, postal codes. And I'm reading someone's code and I see, or I'm reading my old code, and I see that I'm looping over the keys of the names array. What does that mean? It's 0 through whatever the last element of names is. And first off, I'm going to unpack the ith element of names, addresses, and posts into variables to use later. And now I'm going to read through several hundred lines of code represented by ... And look, I'm suspicious of this I. Am I using I plus 1 or I minus 1 anywhere in that loop? Am I looking like, why do I need to know where I am? Do I need to talk to my neighbor, go see what's the difference between the one next to me? Or is it the same because I'm doing grouping logic or something? Do I really need to know that I is 3 when I'm on that one? Or is it just a convenience to make sure that I've got the right element of each of those 3 that are lined up? So I look for that and I see, no, I don't need it I for anything else. So that means that these are parallel arrays and we are interlacing them, or we're zipping them. So I can rewrite it to be explicit by using a zip operator. And that will give me a triad, a little list of 3 elements that I can immediately unpack. And this code is equivalent and shorter, and without the I for every reader to suspect of why do we have I there. The most important thing is not shortness, conciseness, or wondering about the I. It's that what we are doing is now what we are saying we are doing. In both versions, we are zipping over these. We're treating them as parallel. Now it's explicit. So the top line here is the same line. I just shrunk it. And I'm starting to lose coherency of the stuff I have well noted and such. The second line, I'm using the reduction from before. I've paired reduction with Z. And that lets me just change it from having to put Z in between all my items, all my arrays, and putting it up front. There's also a third form that has even more options that's named zip. And instead of going into a for loop, I could directly put it into an array of arrays called NAP for names or addresses, postals. And each one would look like this, and you can't see me pointing to them, like those. And that shouldn't be it. Okay, so if I put an operator after the Z, then that operator happens every pairing. So here I won't, nope. Yeah. No. Okay, on this slide, ignore the bottom half, please. It should be only on the other one. This is the ages of my grandchildren. And wait, how is that? This happened when we were practicing it. There's like 12 slides there that got compressed, and I have to come out of presentation mode to uncompress them. Or got deleted. Okay. No. I'm conflating two different parts of my presentation. My grandchildren have not entered into it yet. Not really. My notes for this slide simply say I need a simpler example. Okay, I have an array of 4 numbers that have no meaning whatsoever, but I need to know what the difference between them are. So I could go back to the keys thing. So I have a handle for where I am and where I want to look in the list, and skip over the first one. So I have A, keys, skip. So it's going to be 1 to whatever instead of 0 to whatever. And then in a map, I can ask it for the current position and the prior neighbor, right? So $_ and $_ minus 1, that's the current one and the one before. And it won't ever be undefined because I skipped 0. And then ask what the difference is. Now that's an interesting use of reduction. I'm not doing anything fancy here. I always know from what's in here, there are only 2 things. There are only 2 things. Why would I reduce over only 2 things? Because it lets me grab this one and last one in one statement from at A. See that? That's a more efficient lookup. I'm not looking up $_ in A and then also looking up the prior one in A. I'm doing both of them at the same time. So I've got a list of 2 things now, and if I do a minus in square brackets, it's the same thing as if I had looked up one minus looking up the other. Does that make sense? I have seen, and I'm starting to use sometimes, this peculiar thing, and I haven't got enough feedback on whether it's confusing or not. So, ignoring that bottom half for a minute, we don't have to do it that way because we've just found Z. And here's a bit of clever. What I didn't mention is what happens with Z if the sides aren't the same size. If I got 3 things on the left and 4 things on the right, what happens? Does it, well, it stops. It stops without error. It's intended, it's by design. If you've got 3 things on one side and 4 things on the other side, it's going to zip 3 things. Doesn't matter which side's which. It stops when the shortest side stops. So how does this work? And I know it's a little jinky until you get used to it. I want the difference of, and now this is where the bottom comes in. I'm going to, A dot skip means I leave out the 6 and all I've got is 9, 11, 13. I'm going to Z minus with the full array. So we got 6, 9, 11, 13. We start subtracting and get 3, 2, and 2. And then when you get to the end, it's okay that there's an extra one there that you haven't dealt with because it's just going to ignore it. 5 minutes left. Thank you. There are a lot of places that you'll use Z that if they're not the same size, something's badly wrong. And you should do something. You should put a check beforehand, or you should use something different from Z, which I get to in another 2 hours from now. So next year. But this is one of the cases where it's fine. It's designed to do that, and it's doing that. And once you're used to seeing this pattern, it doesn't even read that funny. And I'll probably skip over this except to say there is a weird thing that you will see people doing where you can transpose like a 4x2 matrix into a 2x4 matrix just by putting Z in square brackets, and it works a charm. And every time I have to look closely at how does that really work? How can that act? Oh, that's how it works every time, except it doesn't. There is one case where it won't work, and if you don't know about it, it will bite you sometime. If you have a 1x4, it will correctly turn it into a 4x1. If you have a 4x1, it will not correctly turn it into a 1x4 because it can't tell the difference. So you have to, if you're going to use this really compact reduction Z trick to transpose a matrix, you need a check of do you have only one row, and then handle that manually. Okay, X, the cross product. Let's see how much of this we can get. Imagine car dealership, sales report. So we'd write this kind of code. If we've got our makes are Ford, Kia, Audi, and our years are those 3 years, then we would have an outer loop, an inner loop, and report on the make, year, and whatever our sales were. I cannot abandon walking over makes and years and just walk through sales to extract the information because I need the zeros. I need it to report 0 if Ford had 0 sales for a particular year. And I would miss that if I just walked through the level and sublevel of the sales hash. And I would never write this, actually. I would indent that over. Notice here and here, there is nothing. Complete lack of content in between that first open brace and the 4, and between the closing 2 braces. That means that I'm not producing headers, footers, groupings of any kind. That means that these 2 loops form a cross product. 3 makes and 3 years, I'll get 9 lines of output. And I can refactor, just like we did to make zipping explicit, I can refactor to make that cross product explicit like that. Better 1 or better 2? Pardon? Yes, it was absolutely an optometrist joke. Apropos of nothing. It's 2. 1 is doing a cross product, but the reader has to detect it. Thank you. 1 minute. You have to detect it to be able to think of it in that elevated concept. 2, by using the cross product operator, makes it evident to the reader what we're doing. Really? Some of you don't look convinced.
Is that a cross product or a Cartesian?
Is that a cross product or Cartesian product? Yes, and No, I'm going on. It's a decent question I'm not going to answer. So maybe you think X is better but this just doesn't come up that often. Q&A, should I just try and go like an extra 4 minutes here, or do you have burning Q&A that you want to be on camera and all that? Keep going? Thank you. All right, so maybe you think X is better technically, but it just doesn't come up that often. All right, pop quiz. We have some number and it's not 0. What happens when we multiply it by 1? Anybody? Yeah. No, nothing changes. 42 times 1 is 42. Keep that in mind. So these are my grandchildren's ages. And I want to know what are their ages next year. No, that's too easy. I want to know what are the ages the year after that. No, that won't fit on the slides. Okay, yeah, abbreviate it. That'll work. Next year. How we do? Copy it, and then walk over, iterate over the copy. Every one, add 2 to it. Makes sense. Maybe you don't know what that arrow means. That is the read-write version of the dash arrow. Okay. In Raku, as opposed to Perl, by default, age would be read-only, which is an incredible safety feature. It's wonderful. But you need to make it read-write for this to work, and we have a shortcut to do that. I could say IS space RW, but this is shorter, as long as you know what it means. But we wouldn't do that, right? We'd just do that. We'd all do that, right? Instead of this, we do that. Or some of us, we might do this. We don't need to copy and then do something to it. We'll do something while we copy. Map it and add 2 to everything while we're mapping. That gives us the copy and the transformation at the same time. You don't have to do any of that. Is it immediately evident how that works? Because it wasn't to me. So when we had 3 things on one side, 3 things on one side, we got 9 things as output. Here we got 4 things on one side and 1 thing on the other side. And 4 times 1 is 4. So we're going to get the same number of elements in next year as we do is in ages this year. And this is a scaling operation. And you may never use cross product by itself, but this I use all the time. I call it scaling. It's technically only scaling if you're doing addition or multiplication, but I call it that anyway. Costs, and it works on either side. So costs, I can scale by inflation. Bob, I can scale with the concatenation operator to get Bob Jones, Bob Smith, Bob Dobbs.
Okay.
Was that Bob Cat?
Bob K.
Bob K. Oh, for the camera, that is Bob K there. When I wrote that slide, I hadn't seen you this year. And how much time now? Like 1 minute? 2 minutes. This comes up for me. The square root of the sum of the squares, right? Have you ever heard that before? This comes up in math sometimes. I do octonians and it comes up a lot. So what's happening here? In, and I've got an x with an operator and one thing, a scalar. So it's going to raise everything in n to the second power. So now I've got my squares. I've got a reduction operator, which is going to handle everything to the right, no matter anything else about precedence. So I've got the sum of the squares, and then I take the square root of it, and it all reads straight through the square root of the sum of these squares. But not everybody likes that, so sometimes I'll write it the other way. They give the same result. And you can run it. Most of the stuff, if you actually take it and put it in that, it just runs. All right, this is the last fun thing in 1 minute. Pardon? Thank you. Last week, I actually wrote this for the weekly challenge. I'm not going to show how you transform each word into goat, but the very last step in transforming English to goat Latin, which is like pig Latin, but better, is to take each word in the sentence and add an increasing amount of So the lowercase x is the string repetition operator in Raku. And so XX with one thing on the left is going to be a scaling. And on the right, we have an infinite list of 1 to whatever to a constant array. So it's going to be lazy. It's not going to determine the millionth one unless I ask for the millionth one. So what I get, as it shows in the comment over here, is A, 4 A's, and with that constant in my program, all I have to do, I use the X there, I've got the Z down there. I concatenate the right number of A's matching up because I want the first one to be the first one and the second one to be the second one. So I break the sentence into words, map each word through the goat word routine that you don't see here, and zip, concatenate it to the A's and join them on space. Bob's your uncle. And that's beer time. That's our signal here for done. Thank you all. I do crave your feedback. All the speakers here would love for you to go on Sked and rate or put in comments. And please let me hear from you in email if this is of any way significant to you, or if it's not, tell me that. I hope to see you all at the rest of the conference.